Hello everyone, this is problem number 1 from the physics midterm number 1. First, I draw this triangle to represent the pelican as it enters the water at a 20-degree angle from the perpendicular, as is given in the problem description. First, we want to know the x and y velocities of the pelican, and in order to get the x velocity, we need to take the initial velocity, multiply it by a sine of 20 degrees, because that's the angle at which it is entering the water, and the y component is equivalent to the initial velocity times the cosine of 20 degrees. We can write these out to the side to make them easier to read. Keep in mind the y velocity will be negative as it is traveling downwards, so you'll have to add a negative sign to that. Here I write it down in vector notation with the x component first and then the y component following. And since we have no movement in the z direction, that is a 0. Now we implement this in the code, and we need this to be a vector quantity, so we use the vector function, and we actually use parentheses here. I used brackets in the video because that's what you use when you're writing vectors in physics and math notation, but for our purposes in Python we need to use parentheses after vector. And 5.13 is equivalent to v0 sine 20, and negative 14.09 is equivalent to v0 cosine 20 times negative 1. Again, using the vector function turns it into a vector, which will be useful later. Now we need to implement the weight force on the pelican, which is equivalent to the pelican's mass times gravity. Again, we need to make this a vector quantity, so we use the vector function with parentheses, not brackets like I have there. And the weight force is only in the y direction, it is only acting straight down, so we make the x and z components of this vector 0, with the y component being the mass of the pelican times gravity. Now, as far as drag force goes, we multiply the proportionality constant, negative proportionality constant, times the magnitude of the velocity of the pelican cubed, which is the model for drag that we were told to use in the problem description. And by multiplying it by pelican.vel, this turns the quantity into a vector, because we're multiplying a vector by a scalar. And then we multiply it again by another scalar, or the mag2 is the square of the magnitude of the velocity. So it's a scalar times a vector times another scalar, which makes the variable end up as a vector. Again, this is equivalent to our drag force in our problem. After all this, we know that the net force is the weight force plus the drag force, Newton's second law. And now we implement Newton's second law again to get the new velocity of the pelican. And we take the initial velocity of the pelican after each iteration, which is pelican.vel, and then through applications of Newton's second law, we get F net, which was calculated earlier, divided by the pelican's mass, times the change in time, or delta t, which is altogether equivalent to our acceleration. So our initial velocity plus acceleration equals the new velocity. And then to update the position of the pelican, we take the initial position of the pelican where it was before, and then we add on the new velocity that was just calculated in the prior step times the time step, or how much time elapses. So in our case, that would be delta t. It's the velocity times how much time that velocity was acting. Gives us the updated position. Thanks.